Are we live now? Yes. So, hello guys. Good afternoon. This side Ajay Kumar, your chemistry faculty, going to deal track 1. That means basically the physical chemistry. The earlier lectures you might have heard in which Birmani sir classified chemistry into 3 categories: physical, organic and inorganic. So I would be basically dealing the physical chemistry, right? So the chapter which we are going to discuss in today's class is atomic structure, about which we will talk in 5 to 10 minutes. Let us have some interaction. Good morning, sir. Chaitanya, it is not morning, man. Hana. Yes, good evening, good evening. Suma, yes, hi. Hi, Suma. Divya Jyoti, hi. Yes, hi. Bapuji, good evening, Bapuji. Yes, good evening, guys. Good evening. Yes, hi. Hi, Vallabha. Hi. Hi, who is this monkey? Yeah, hi. I cannot call you as monkey again, but please change your name. Virat Kohli. Yes, Virat Kohli. Yes, hi. Yes. How are you, sir? I'm fine. I would like to know what about you. How are you people? How are you people? Sir, what's your name? This side Ajay Kumar. This side Ajay Kumar. I'm from Odisha. Okay. And I belong to the border region. I'm from Odisha. Andhra and Odisha border. Typical Odia guy here. Okay. Good, sir. Good. Yes. Glad to know you guys are doing well. Yes, it's Ajay Kumar Panigrai. Correct. Yes, I think you know me, Suma Sri. You are in class 12th, I guess. Yes. Sir, I am also from Odisha. Meena. Okay. Great to know about that. I am from Rayagada. Yes, someone asking where are you from? I am from Rayagada. It is in Odisha, basically in the border region. I am from Rayagada. Sir, do you know Telugu? I know a bit of Telugu. I can speak a bit of Telugu, but this is not the right place, I think. Okay. Whenever we interact with each other, that time we may discuss something in Telugu, but it's better to keep everything in English. Okay. Bagunnara, sir. Yes, I'm somewhat good. I want to know how you people are doing. One of my friend is from Odisha. Yes, glad to know. India is a country in which we have unity in diversity. Yes. People from different region are having great friendship. Glad to know about this. Hi, sir. Yes, hi. Hi, Ganita. If I'm not wrong, it is Ganita maybe. Yes, hi everyone. Hi. What's your name? This side, Ajay Kumar. I will write my name here. This side, Ajay Kumar. Okay, your chemistry faculty. Your chemistry faculty, this side Ajay Kumar. Sir, I am from Maharashtra. Yes, Maharashtra. Yeah, I know. I mean, in Gosalites, we have students from different states. That is the beauty of Gosalites. I mean, I was working in different institutes, but they're mostly students were there from one locality or else mostly from 2-3 states. But in Gosalites, we have students from so many states. Right. Rayalaseema. Yes, I was there in Kadapa. Yes, I was there in Kadapa in the Akash Institute. I was working. Okay, I was there in Kadapa. It is not a good place as this Vijayawada. I'm talking about weather point of view, right? Whether you have to adjust, rest, everything is okay. Kadapa was also good and Vijayawada is also good, but weather is not that good. I didn't like it. I am from Anantapur. Okay, Anantapur. Most of the places in Andhra Pradesh is having a bad weather, I guess. Yes, Kurnool, Jammu and Kashmir. Honky, you're from Jammu and Kashmir. Man, you please change your name. Yes, Srikakulam. Yes, it is close to my place. Anantapur, Kurnool. I am from ATP. What is ATP? I don't know what is ATP. Chalo. Europe. Who is this guy from Europe? I have never taught any student from Europe, basically. Only I have taught to Indians and some students in Dubai. I have some students in Dubai, but not from Europe and all. Vijay, I am from Vijayawada. Great. Chalo. Adenosine triphosphate. You are from ATP. Acha. Adenosine triphosphate. Yes. Great. You are a biology student. Yes, you are a biology student. I also have studied biology, man. I too know what is ATP and ADP. Chalo. Anyway, let us start the class. So, guys, in atomic structure, let us first try to understand what is this atom is. Okay. So, talking about atom, this atom word is derived from the word atomio. It is a Greek word, atomio. You have to pronounce like atomio. The meaning of this word is non-divisible. Means what? From where we got this word atom? Atom is coming from the word atomio, and atomio means non-divisible. That means atom is a fundamental particle of matter which cannot be divided, right? Can anyone tell me who gave this theory in which the scientist told that atom is the smallest particle of matter that cannot be further divided? Anyone? You have studied this in class 8th and 9th? Yes, Dalton. Great. It is John Dalton, correct? So talking about, it is John Dalton. We will go for the Dalton's atomic theory. Briefly, we will discuss about Dalton's atomic theory because this topic we will discuss in some basic concepts of chemistry as well. So in Dalton's atomic theory, what we came to know? The first point in Dalton's atomic theory was atom is the smallest particle of matter. According to Dalton, this is the smallest particle of matter. That means it cannot be further divisible, right? This is what told by John Dalton, and he was a failure. You should not say he was a failure. This model, this theory has failed because we got some fundamental particles, right? But the thing is, he is the first scientist. He has given the theory, which is the first theory for atomic structure to elucidate the structure of an atom. So talking about Dalton, don't tell that he is a failure, right? You might be knowing ki if you are failing today, you might be getting success tomorrow. So he told that atom is the smallest particle of matter, and he told atoms can neither be created. You might have studied all these things, right, earlier. Can neither be created nor be destroyed. Right. Now, by saying this, what he mean to say? He is saying that in a chemical reaction, when reactant is converting into product, if left side you have 100 grams of reactant, the product will also have 100 grams of mass. That means the reactant and products will have the same masses. Mass will not be different in both the sides. That means mass is not created, mass is not destroyed. Mass is not created means atom also not newly created, not destroyed, right? Hey, Vidya, I am from MAP, boys. A motivator and best physics teacher. You are, sir. I am not a physics teacher, man. Hatmika, it is chemistry teacher. Yes, law of conservation of mass. Very good, Sindhu. It is law of conservation of mass. So, Dalton's atomic theory is justifying the law of conservation of mass. Law of conservation of mass. LOCM. That is being justified by atomic theory, right? And several points are there which we can discuss. And what else he told? He told that atoms rearrange to convert reactant into products. right? The reactant is converting into product means in the particular chemical reaction, the atoms will get rearranged, but atoms will not get destroyed, will not get created. This is all told by Dalton, and several other points are there, which is not in our context now. We will discuss sometime, right? Now what I can say is, in this theory, what is the drawback? The drawback, if I talk about, the drawback which is related to our topic now is, like, if you have, suppose, comb and you are rubbing, if you have comb rubbed with dry hair, then what will happen? What is going to happen is, comb will get a charge over here. What is the charge that will come on the comb? Comb will get a negative charge, whereas the dry hair will get a positive charge. Are you getting my point? There are charges being created, negative charge and positive charge. How to know that charges are being created? We got to know that charges are created because when you are rubbing this comb with dry hair, after that, if you show that comb to small pieces of paper, it will attract them. That means definitely some charge is there. Static energy, yes, it is some charge which is present on the comb, which is attracting the pieces of paper. Now, why it is happening? Correct. Losing and gaining of electron. Perfect. Basically what is happening over here is, from the dry hair, some electrons are getting transferred to this comb, so that it is losing electron, getting the positive charge, and comb is gaining the electron to get a negative charge. When something is related to negative charged particle here, the loss of electron, gain of electron, we are saying. But what is that electron? According to Dalton, there is no electron, no proton, nothing. Atom is the smallest particle. That's why Dalton is proved wrong over here, right? So for that sake, what we can say is, we got the fundamental particles, subatomic particles. So now we will go for discovery of subatomic particle. Right? Discovery of subatomic particle we are going to discuss. So that's why theorem was wrong. Yes, it is not theorem, it is theory. Theorem is there in mathematics, right? That's why his theory is proved wrong. Right? Subatomic or fundamental particle. Yes, it is subatomic particles. Let us talk about those subatomic particles. So what we got to know is, atom is not the smallest particle of matter. Rather, atom has some smaller particles like electron, proton, neutron, right? And so many are there, but we will discuss these three basically. May I know what are the other fundamental particles, or whatever the smaller particles are present inside the atom? Can anyone tell some other particles name? Yes, all theorems are failure and not what? And they are RIP. Yes, you are correct. All theorems, all theories are failed. Yes, one by one we will discuss all those theories, right? One by one we will discuss alpha, protons, neutrons, muons, mesons. Perfect. So many are there, right? But we will restrict ourselves to these fundamental particles, right? In our syllabus, we will discuss about electron, proton, and neutron. Now let us start studying about discovery of electron, right? For discovery of electron, what we will talk about is, we will start with the cathode ray tube experiment. Cathode ray tube experiment. Which we call as CRT experiment. Cathode ray tube is called CRT, so it is CRT experiment. In this CRT experiment, what we will do is, what is first of all cathode ray tube? Let us try to understand. So basically, we will have a cylindrical tube, right? A cylindrical tube will be there like this, in which a small, guys, this type of tube will be there, in which here we will have some connection with vacuum pump. Why it is connected to vacuum pump, I will tell you. But you see how this experiment was conducted. So we have a cylindrical tube. This is made up of glass tube. Very hard glass will be there. That hard glass tube is there and having a connection with the vacuum pump. Here we will take metal plates. Very thin metal plates are there which are connected to the external source of battery, you can say, or very high voltage. Right? This type of very high voltage is there. Now, this terminal is positive and this terminal is negative, right? Positive terminal attached to this metal plate. So this metal plate will also get positive charge. Negative terminal of the battery connected to this metal plate, so it will also get negative charge, right? Now, negative charged electrode is called as the cathode, whereas the positive charged electrode is called as the anode. Right? You might not have studied about cathode or anode, but I'm sure that you people might have studied about cations and anions. Can anyone tell me what is the charge in cation? What is the charge in cation? Cathode is negative. What is the charge in cation? Plus, positive, 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 positive. Yes, it is positive, not negative. Some people are writing it is negative. It is not negative, it is positive. Yes, it is positive. So cathode is negative whereas cation is positive, because we know that opposite charges attract each other. The positive charged particle will be attracted towards negative electrode. So positive charge is cation will be attracted towards the negative charged electrode, cathode, right? So this is the cathode, this is the anode we have. Now here basically what will happen, whatever this tube is there, this tube is called as discharge tube. This tube is called as a discharge tube, and because it is in this experiment we are talking about cathode ray, in this tube somewhere cathode ray will be coming. That's why it is called cathode ray tube also, CRT, cathode ray tube, discharge tube or cathode ray tube you can say. Right? Now what is going to happen is we have a cylindrical glass tube, very hard glass tube, inside which we have these two metal plates connected to the external battery, and this battery is going to produce 10,000 volt, even more than that also. Very high voltage, right? To the household supply of current, we are getting how much voltage? What is the household current voltage? What is the household current voltage? 220 volt, 220. It is not 240, 250, it is 220. Yes. 220 volt is the current over there, but here what we have, 10,000 volt means very high voltage we are supplying here. Why we are supplying this volt? I will tell you. We are having this high voltage, and inside this glass tube very low pressure will be maintained. Very low pressure. How much pressure? Someone has written some pressure, right? So low pressure up to 10 to the power of -4 torr, right? What is this torr? What unit it is? We will discuss later. But I can say that the pressure inside this glass tube is very low, whereas the voltage applied is very high. High voltage and low pressure is there in this experiment, right? Why high voltage is applied and why low pressure? We will talk about that. Now, what we have observed is when we are doing this type of setup, we are having a very high voltage, then we have seen that from the cathode some ray started and they are traveling towards the anode, right? Basically we can't see this. This is an invisible ray. We can't see this ray, but what we have observed is this type of some rays, invisible rays, are coming from the cathode and going towards the anode, right? Why these are going towards the anode? Basically these rays are having a negative charge. Remember, these rays are having negative charge. Because they have negative charge, definitely they will be attracted towards positive electrode. Opposite charges attract each other. So what will happen is from the negative electrode cathode, the rays will start and will go towards anode. Because they have started from the cathode, that's why their name is cathode ray, right? The name of this ray is cathode ray. The reason is they have started from cathode. So these are cathode ray, right? Yes, these are the cathode rays. the charge in the cathode ray is negative. Okay, negative charged ray. Negative ray, negative charged ray, cathode ray, whatever you can say, these rays have been started from this cathode. Now the question is, why this high voltage is required? So the answer to this question is, if you have a high voltage, then only the metal will eject the electron. Basically from the metal surface, the electrons are getting ejected and going towards this anode. And when these electrons will get ejected, if you supply a very high voltage, right? If you supply a very high voltage, then only the electrons will get ejected. That's why we are supplying this high voltage. That is okay. Now the question is, why low pressure is maintained? So guys, remember, if you have low pressure, how we are maintaining low pressure? By taking away the gas from this tube. From this tube, some gases are going outside. You see, with the help of vacuum pump, you are taking out some gases. When you are taking out some gases, very low pressure is there inside. If less amount of gas is there inside, then only this cathode rays can travel easily. Or else what will happen? Or else what will happen? The cathode ray will be colliding with the gas particles. If more gas particles are there, they will collide with the gas particle, so that cathode ray cannot move that easily, right? So that cathode ray cannot move that easily. So tell me why we are having high voltage. I have a question. Why we are supplying very high voltage? I too play Free Fire. Okay, you may play Free Fire, but please answer to my question. Why we are having high voltage here? So change, blue is not good. Okay, blue is not good. I will change the color to yellow. Okay, yellow, dirty fellow. Don't say this way. Okay, or else I will make you sit in buffalo. Now you people tell me, metal will eject electron. Very good. So we are having very high voltage so that the metal will eject the electron. Now that is okay. Why low pressure is maintained? Okay, it is okay. Why low pressure is maintained? Low pressure is maintained to eject ray easily. Yes, so that the electron, the ray, whatever is there, that will easily move, right? It will easily move. Exactly. It is like when you are traveling, when you are riding a bike, suppose in your opposite direction wind is flowing, then your speed will decrease. But if wind is not there, nothing is there, easily you can move. The same thing, if more gases will be there, this cathode ray will bombard, will collide on the gas, so that they cannot travel that easily. Correct, perfect. Now the thing is, from here from the cathode ray originated, they started from the cathode going towards the anode. This is what we have observed. Now what I can say is, in this experiment, what we are doing, a cylindrical hard tube is taken, and this cylindrical hard tube is taken, that is called as discharge tube. Why it is called discharge tube? Why the cylindrical tube is called as a discharge tube? Conclusion. Yes, we will go to the conclusion. You wait. Have some patience, man. If gas is not removed, rays cannot travel through it. Yes, if gas is not removed, gas cannot travel through it. That is correct. My question is, what is discharge tube? Why it is called discharge tube? The reason being, inside this glass tube, the electrons are getting ejected, they are getting discharged. That's why it is called as a discharge tube, right? A cylindrical, what are the points we are doing? In this experiment, a cylindrical hard tube is taken, and that is known as discharge tube. And what else we are doing? Discharge tube is also called as CRT, cathode ray tube. This is CRT, cathode ray tube. That CRT is connected with what? Two metal plates, and these metal plates are called as the electrodes. They are called as electrodes. The negative charged one is cathode and positive one is the anode, right? Now, if you talk about third point, what I can say? High voltage and low pressure maintained. I'm writing the key points what we are doing in this experiment. Low pressure is maintained. Low pressure is maintained so that what we have observed, this is what we are doing in this experiment. What we have observed, if you talk about what we have observed, I can say that the observations I'm writing, the first point that we have observed is from where the ray has originated, from where the ray has originated, from where the ray has originated, from where ray has started. Your voice is not audible. My voice is not audible. If it is, then how students are answering? I hope there is some problem in your side, Suma, right? So observation, I can say that from cathode, some ray has started and that is moving towards anode, right? That is moving towards anode, and this ray is called as, and this particular ray is called as cathode ray. The ray which started from cathode is called cathode ray, right? I would like to tell you one interesting point. In cathode ray experiment, the ray is starting from cathode. So we have another experiment which we will discuss in the next class, that is anode ray experiment. Can anyone tell me from where the ray will start? Guys, my question is, in cathode ray experiment, the ray is starting from cathode. In anode ray experiment, where the gas will start? Yes, so many students are answering that it is anode, but you are wrong. In anode ray experiment, the gas will neither start from anode nor from cathode. Sounds interesting, right? Yes. It sounds interesting. That will not start from anode. In anode ray, it will not start from anode. Only in cathode ray experiment, the ray will start from cathode. Why it is? I will tell you in the next class. In anode ray, why the anode ray will not start from anode, I will tell you in the next class. But let us talk about the cathode ray. Okay, in cathode ray experiment, the ray will start from the cathode. That is called as cathode ray. The second point is the ray is invisible. You cannot see this ray. The ray is invisible. Then how can we know that the ray is there? If something you can't see, how can you say it is there? The thing is, like, I can tell you that in this experiment, whatever we have done, guys, you see here carefully, the diagram you see carefully, what we are doing is, we have the anode, we have the cathode, ray has started from the cathode if we are doing all these things. Now the thing is, if this is happening, this ray we cannot see. Okay, this ray is invisible ray. But what we will do is, we will make some holes on the anode. Anode is there, this anode, we will make some holes. Like this type of anode is there. Let us say anode looks like this, in which we have made some holes on the anode surface. On the anode surface, we have made some hole. What will happen is, these rays are coming from the cathode and they will pass through these holes, so that after passing through the hole, they will hit on the back side. On the back side, what we will have, is some fluorescent material or phosphorescent material. Okay, fluorescent or phosphorescent material. Some fluorescent or phosphorescent material will be there, on which these rays will be hitting. These rays are going, you see, these rays are going, started from cathode, going straight this way. After passing through these holes, they will hit on this phosphorescent or fluorescent material surface. After hitting, they will glow, right? You might have seen that some jatra will be there, right? Mela or jatra, whatever you say. In that we might have a magic slate. You might have seen magic slate, right? In the magic slate, if you write something with a pen, the pink color magic slate will be there. If you write something, then it will be getting displayed. And if you turn, or just like if you wipe this way, then it will get wiped, right? So the similar way, here we have some material which is fluorescent or phosphorescent material. When this ray is going and hitting over here, here some glow you will find, some green color glow you will find. Okay, green is glow, green glow, green or blue you can say, some greenish glow will be there. Actually the cathode ray is colorless, it is having no color, you can't see that. But once it is hitting on this screen, the screen is basically made up of zinc sulfide. We will take zinc sulfide screen. Okay, we can take zinc sulfide screen or any fluorescent or phosphorescent material. If this is hitting on this screen, you will get some glow, right? From there we have concluded that the cathode ray is passing this way and passing through this hole, hitting over here is giving the green glow. Okay. Yes, radium also glows, but it is not radium, it is zinc sulfide basically we have taken here, right? You might have seen in the traffic signals also, in the traffic signal, or I should not say traffic signal, whatever the road signs will be there, traffic signs over there, if light falls, they will be seen very clearly. If night time you are flashing your light on the signals, that is the signal boards, then you can see them very clearly because they are also made up of this fluorescent or phosphorescent material. In the bike or cycle, car also, backside we have, in the bottom part of the indicator, we have some illuminating material, this fluorescent or phosphorescent material. When light falls on them, they will look very bright. The same type of fluorescent phosphorescent material, zinc sulfide, is over here. When it is hitting over here, you will get some glow over there, right? So now what I can say is, first point we have discussed, the ray is invisible, but when it will become visible, when the ray will become visible, reflectors, very good, it is reflector, right? Now I am from South Africa, very good man, very good. Yes, Bhargav, you are from South Africa, your name seems to be you are from India only. Anyway, so what my point is, the ray is invisible, but once the ray hit zinc sulfide screen, then what will happen? It gives a glow. It gives a glow, so that you can say that there is some ray, there is some invisible ray which is passing through from the cathode going towards the anode and hitting on the surface, right? Now scientists were not having any idea. Initially when we have done this experiment, that time we were not having any idea ki the ray is consisting of, it contains negative charged particle, right? That time they were not having any idea. That's why they told it is some magical ray starting from cathode. That's why it is cathode ray, right? That is cathode ray. So that cathode ray cannot be seen with naked eye when it is passing through the glass tube, but once it is hitting on the screen only, it will give a green glow. Third point what I can say is, ray, the cathode ray, moves in a straight line. It will move straight only, moves in a straight line with very high speed, almost speed of light, guys, very high speed, almost 10 to the power of, I can say almost range of 10 to the power of 7 meter per second. Almost, it is the range. If you know what is the speed of light, can anyone? What is the speed of light? What is the speed of light? Arey bol bhi do yaar. What is the speed of light? Suma, who asked? What is the speed of light? 3 into 10 to the power of 8 meter per second. Very good, very good. Sadhana Padhi. Sadhana, are you from Odisha? Because mostly in Odisha only we have Padhi kind of surname. Padhi. Anyway, yes. 3 into 10 to the power of 8. Yes, you guys are correct. So speed of light is 3 into 10 to the power of 8, whereas this is almost 10 to the power of 7. Means this cathode ray is almost having same speed as that of light. Remember, there is no material particle which cannot move faster than light. Nothing can move faster than light. But this cathode ray can move at approximately same speed as that of light. Not exactly same, but almost same speed, right? So this ray moves in a straight line with very high speed unless external electric field or magnetic field is present. If you don't have electric field or magnetic field from outside, till now we have not discussed any point related to electric field or magnetic field. So suppose that electric field is not there, magnetic field is not there, nothing is there. Then what? The ray will go straight, right? The ray will go very much straight. But what if you have some electric field or magnetic field, right? The fourth point I can say, if electric field or magnetic field is present, then what will happen is ray gets deflected. The ray gets deflected. It is like when you are studying, and you are not using mobile phone, okay? You are not using mobile phone, you are just studying with your book and pen, paper, all this. That time you will be focusing only on the studies. But if you have WhatsApp, Instagram and all these things along with your studies, then you will get distracted. The same way, if the cathode ray is there, that will go straight if there is no electric field, no magnetic field from outside. But if you have external electric field or magnetic field, the ray will not go straight. It will interact with those electric field or magnetic field. This cathode ray is like you people only. The cathode ray is like you people. You see, now you are not focusing on studies because you are getting deviated. You are getting distracted in the chatting. You guys are getting distracted in the chatting. The same way, this will also get distracted. It will get deviated, right? How it gets deviated, you see, if in the cathode experiment, you go back to the cathode experiment, what we have done here, you see, this type of thing we have drawn, right? Here, if I have external electric field, this is some external electric field, okay? Here suppose positive charge is there, negative charge is there. External electric field means positive and negative terminal is there outside. If external positive and negative terminals are there like this, then what will happen? This ray contains what charge, guys? What is the charge present on the cathode ray? Guys, what is the charge present on the cathode ray? The discovery of proton credited to Rutherford. No, it is not Rutherford. Proton was discovered by Goldstein. Okay. Anyway, the charge on cathode ray is negative. If it is having negative charge, which side it will be getting attracted? In the external electric field, which side it will get attracted? Yes, cathode ray has negative charge, but which side it will get deflected now? Positive, because opposite charge attracts each other. So now when this cathode ray is going, if external electric field not there, it will go straight. But in the presence of external electric field, it will not go straight, rather it will go like this and it will get deflected towards the positive plate, right? Are you getting my point? It will go straight if there is no external electric field, but if electric field is present, then it will get deflected towards the positive plate of the electric field because it has negative charge. Positive plate has positive charge. Opposite charge attracts each other, right? That is the nature. That is the law of nature. If electric field or magnetic field is present, ray gets deflected towards a direction, right, which is observed for a negative charge. So for a negative charge, which direction it should get deflected? That side the ray is now getting deflected. From there, what we can concluded? The conclusion is cathode ray contains negative charge. That's why it is getting deflected towards positive plate of the electric field. External electric field means you may connect so many batteries. In battery, we will have positive and negative charge, right? That way, to the positive plate, it is getting deflected. That's why it has negative charge. Now, next point, if I talk about cathode ray, which contains electron, right, has mechanical effect. Has mechanical effect, or you can say has mechanical energy. Mechanical energy means what? This is your cathode, this is your anode, right? This is cathode negative charge, this is the anode positive charge. From the cathode, when the ray is going like this towards the anode, this is cathode and this anode. I am not drawing the complete diagram. So cathode and anode is there. When the ray is going like this, what will happen? Suppose in between you are placing a fan kind of thing, this kind of fan, very small size fan, right? You might be knowing, like in some chocolates or something like that, you get this small, very small size fan, right? If you blow air, it will be keep on rotating, the blades will be keep on rotating. So that way, will you repeat all this after school reopen, sir? Why are you asking this question? You should listen to this class itself, na? Okay, so the thing is like, from cathode, the ray is going this way. When it hits this fan, very small fan, then what will happen? The blades of the fan will start rotating in a direction. Means what? This cathode ray has some mechanical energy. It has some mechanical energy. With that energy, it is transferring energy to the fan, so that fan blade is rotating, right? Okay, that means it has mechanical energy, I can say. Next point, I can say that cathode ray has negative charged particles, not waves. Cathode ray, initially scientists were thinking that cathode ray is a wave, but instead it is not a wave, it is made up of negative charged particles, right? Earlier they were telling that, sir, photons, the energy we will study. Yes, we will discuss about photons anyway later. So my point is cathode ray has negative charged particles, but it is a particle, not a wave. That is what my point is, right? Now, next point I can say cathode ray, if going this way and hitting to some object, if it is some object, the cathode ray is going and hitting this object, then what will happen? Heat will be produced on the object. Can anyone tell me why it is happening? Cathode ray is going, hitting the object. Why the object is getting heated up? Why its hotness increases? Why and its temperature increases? Can anyone tell me? Reaction. It is not reaction. It is because energy can neither be created nor be destroyed. Cathode ray has some energy. It has mechanical energy. Once this ray is hitting the object, its mechanical energy will be getting converted into heat energy, right? The mechanical energy converts into heat energy. That is what is going to happen here. Now, the next point, if I talk about, that is cathode ray has negative charged particle, and those negative charged particles are called as electrons, right? This negative charged particle, cathode ray, does not depend on nature of, first one, gas taken inside the tube, inside the discharge tube we are taking some gas, right? Very less amount of gas, but some gas is there. So what gas you are taking, irrespective of that, you may have oxygen gas, nitrogen gas, hydrogen gas, this gas, that gas, whatever the gas may be. If gas is taken, right, whatever the gas is taken, cathode ray always contains electrons. But interestingly, in anode ray, this is not going to happen. Remember this point. That's why I'm marking it is important, right? Why it is important? Cathode ray does not depend on the nature of the gas, but anode ray depends on the nature of the gas, which we will discuss in next class anyway. Now talking about the next one, it does not depend on the nature of electrode. Electrode means what? Metal plates. Cathode and anode, two metal plates we have taken. Whatever the metal plate you take, whatever the gas you take inside, always the ray will start from cathode, will go towards anode, and that ray will always contain what particles? Yes? What particle will be there in that ray? What particle will be there in that negative charged particle? What is that particle? What is the name of this particle? Electrons. Yes, yes, yes. Very good, very good. That is negative charged particle, electron. So always electrons will be there. In cathode ray experiment, always electron will be there. So can anyone guess, in cathode ray experiment electron is coming out, so in anode ray experiment what particle may come? Cathode ray experiment electron is coming out, in anode ray experiment what particle may come? Proton, not neutron. Yes, so many students are guessing proton. You guys are correct, but terms and conditions apply. What is the terms and conditions? In cathode ray experiment always electron will come, but anode ray experiment always proton will not come. That is the interesting part. Now you definitely having some doubt, like why anode ray will not contain always the proton. Always proton will not be there. It will be like proton may be there, but proton may not also be there. But cathode ray always contains electron. From this what we understood? We have taken some metal, from that metal electron is coming. Whatever the metal you take, electron will come for sure. That means that electron is present here, there, everywhere. All the elements, all the atoms will have electron. Electron is conclusion from all this. I can say conclusion. Someone was asking conclusion. I am telling now the conclusion. Conclusion is all the atoms contain, all the atoms or all the matter, all forms of matter, atoms contain electron as fundamental particle. Electron will be there for sure. Proton will be there or not, neutron will be there or not, that we will discuss later, but electron will be there for sure in all the species, right? Now what else we can discuss over here is, this is the experiment through which cathode ray, in this cathode ray experiment we got to know about electron. Electron is the particle. Conclusively I am saying electron is the particle which is coming from cathode towards anode. How we got to know that this ray is started from cathode and going towards anode? Because we have made the electron to hit on the ray to hit on the surface, zinc sulfide screen, which creates the glow, from which we got to know that cathode ray contains electrons, right? Now Thomson has studied something called E by M ratio of this cathode ray. E by M ratio of cathode ray. What is this particular thing you see here? E by M ratio, if you talk about, E means, here E means charge, E not electron here. E means charge on cathode ray, right? M means mass of electrode, mass of electron, or mass on cathode ray. Mass of the cathode ray, you can say. Mass of cathode ray means cathode ray contains electron. The mass of the electron I am talking about, right? Mass of electron, E is charge on the cathode ray or charge on the electron. Charge on electron and mass of electron. This individually we did not calculate. Thomson is the scientist who calculated E by M ratio, but he did not calculate individually what is the charge value, what is the mass of electron, right? I hope you people must be having little idea about what is the charge on the electron. Can anyone tell me what is the charge on the electron? In class 10th also it was there, if I'm not wrong. What is the charge on one single electron? What is the charge on one single electron? It is negative charge, but how much is the charge? How much is the charge on single electron? Anyone? If you know, well and good. If not, not a problem, we will discuss. 1.6 into, yes, someone is writing, partially correct, but not completely. 1.6 into 10 to the power of minus 19 coulombs. Perfect, perfect, perfect. So many answers are coming. If you guys already know, well and good. If you have searched in Google and you are saying, then it is not good, man. Okay. Anyway, what I can say is charge on electrons, some value you told, that is correct. I will not write here because we will discuss about that later. and m is the mass of electron. Individually we know E and m value, both we know now. But that time when Thomson was doing this experiment, we were not having the value of charge on electron, mass of electron individually. But through his experiment, what he told is, what is the ratio of charge and mass? So what he did is, he has done the same experiment. Thomson calculated E by m ratio for electron. For electron means for the cathode ray. For the cathode ray, for the electron, E by m ratio he calculated by this experiment. What is the experiment he has done? The same thing, whatever we have done earlier, similar setup will be there. Right? Basically this type of setup will be there. Here we have zinc sulfide screen. Here what we have is, this is my cathode which is having negative charge, and here we have anode in which hole is there. In the anode hole is there, this is the cathode, right? From the cathode the ray will start and will go like this, and hole is there, na? Only we will make one single hole here for simplicity. Here we have one single hole. Through this hole the cathode ray should pass like this. But what will happen is, what Thomson has done is, he has applied external electric field. Positive charge, negative charge. External electric field is applied. So which side the cathode ray will get deflected? Please tell me which side the cathode ray will get deflected. Which side cathode ray will get deflected? Sir, for H plus ion, will there be any electrons? For H plus there is no electron, man. I told for atoms only electron is fundamental particle. H plus is not an atom, it is a proton. Right? It is positive charged species. Right side. Right? What right left? Towards positive. Correct. You guys are correct. So this ray will get deflected towards positive terminal. So what is going to happen is, the ray will go like this and will get deflected this way. And he will hit on this point. Right? Suppose that instead of having electric field, you have some magnetic field. Like you have a magnet here. Right, so outside only magnet here, in which north pole of the magnet is there, south pole of the magnet is there, right? So what will happen is, the ray will go like this straight and will get deflected this way, right? Magnet is present like this. What we are doing, we have kept magnet like this, electric field like this, and ray direction is like this. Total 3 planes are there: XY plane, YZ plane, and XY plane, YZ plane, and ZX plane. These 3 planes are there. In these 3 planes, these 3 things are there. The ray is passing through one plane, this magnetic field is there in other plane, and this electric field is there in the third plane. Total 3 planes. All the 3 planes are mutually perpendicular to each other. So here what is happening, if magnetic field is there, it is getting deflected this way. In the electric field, it is getting deflected this way. But suppose that electric field, magnetic field, both are not there. If both are not there, how the ray will go? Can anyone tell me how the ray will go if there is no electric field, no magnetic field? Yes, we will conclude the class. You please let me know, if there is no electric field, no magnetic field, how the ray will go? Straight line, straight. Yes, it is straight. So it would have gone this way straight and would have hit over here. So we are getting 3 points, point A, point B, and point C, right? Now what he has done is, he has balanced this electric field and magnetic field. When electric field is equal to magnetic field intensity, both are same, then also ray will go straight. Then also ray will go straight. If both are not present, then also straight. If both electric field and magnetic field are equal, then also straight. By doing this, what he has done is, he has got some formula, E by m, in terms of B and V. What is B and V? I can say B is magnetic field strength and V is the voltage. So how much voltage you are supplying here? You know that, right? You are only having this electric field. So how much voltage you are giving? You know this voltage value V. You have this magnet, means you know how much is the strength of this magnet. The strength of the magnet is represented by magnetic field strength B. So if you know this B value and V value, if you put those value, then you will get the E by M value. So what is the E by M value he calculated? E by M value for electron is equal to 1.75 into 10 to the power of 11. E is charge, coulomb per mass is in kg, coulomb per kg. This value he got, right? So to conclude the class, I will not give any homework for the first class, right? If you want, if you have NCERT, you please go through this topic. Okay, you please go through this topic. How is Pant sir, chemistry faculty? He is fine. He is fine. I recently have interacted with him. He is very much fine. Okay, my point is, you guys go through this topic, cathode ray experiment, if you have NCERT. And suppose you don't have NCERT, then what you will do is, yes, what you will do is, you just surf the internet and try to read something about this cathode ray experiment. I have to, before ending up the class, I have one question for you. Yes, I have one question for you. Cathode ray, in the cathode ray experiment, so can you send your PDFs? Yes, it will be sent, guys. So what I can say is, sir, your number, it will be shared in the channel itself. You might be having some group. In that group, it will be shared. My last question is, guys, what is the E by M value of cathode ray? It will be this value. Will it be always same? Cathode ray, in cathode ray experiment, always we will get E by M value is 1.75 into 10 to the power of 11. So in the next class, we will discuss about anode ray experiment. So in anode ray experiment also, E by M value will come. Now my question is, anode ray experiment, will the E by M value will always be same? Yes or no? Think about this and let me know. Then we will end up the class. Justify your answer. Justify your answer. No, you guys are saying no. Can I know why it is? Mass is different. Very good, man. Very good. So that is the reason. Basically, in cathode ray experiment, always the ray contains electron. Always the particle is same electron. If particle remains the same, the value also will remain the same. But in anode ray experiment, the particle always is not proton. It may be some other particle also. If particle changes, then the E by M value also will be different. Yes, mass is different. Correct. Right? So rest of the thing we will discuss in next class, guys. I hope you all have understood the class. And from my side, what I can say is, you guys please go through this topic once. Okay, I'm sharing the QR code. Okay, QR code is being sent. Now, you can go through the notes. Okay, have a great time ahead. Chalo. We'll meet in the next class. Bye, guys. Bye, 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 bye. Vallava, bye. Yes, Ishwari, what is your name? Yes. Bye. Chalo. Bye, guys. Bye. Have a great time ahead. Bye.